Okay, the recording is started. Please confirm if my screen is visible. Are you able to see my screen?
Visible, sir.
Okay, okay. So let us do a quick recap about the yesterday's session. Okay, so we were discussing about bitwise operators, right? We were discussing about bitwise operators, and we have completed discussing the yesterday we have completed discussing about the right shift operator. So today we will complete the remaining two operators, which are unsigned right shift and bitwise complement operators. And I don't think we need a quick recap for this. So it is just like a mathematical calculations, self-explanatory. So if you have any questions on this, I will that questions would be answerable with this uh, you know uh, unsigned right shift operator. Whatever the questions that you have, that questions will be answerable with this explanation. Okay. So let's get it started. So we want to discuss about what we want to discuss about the uh, triple right shift operator, and the last topic is what bitwise operator. Let us go ahead with the triple right shift operator. Triple right shift operator. Okay. So what is the triple right shift operator? What is the symbol? By default, the symbol is going to be like this. So you are going to use three angular braces that is pointing towards right. Okay. This is how you can represent the triple right shift operator. Okay. So it is also called as it is also called as unsigned right shift operator, okay, or lo- logical right shift operator. Okay. So both are same. You may get a question like what is unsigned right shift operator, or you may get a question like what is logical right shift operator. So both are one and the same, right? And now if you want to understand this, so I will make a pointer. So this is the point to be noted. By default, it would use the integer data type. By default, it is going to use the integer data type. What does it really mean? What does it really mean? In order to understand this, let me write a small program. Okay. I want to do what? I want to do byte a equal to 5. I am just assigning the value 5 to the variable a. Firstly, then what I am doing, I am using this variable. I want to use the triple right shift operator. Okay, triple right shift operator for 1. Okay, so it is indirectly like 5 is getting triple shifted to 1. Both are one and the same. So but the data type of the a variable is byte. Okay, and if you see here, if you go back and see my explanation, by default it would use the int data type. What does it really mean is, internally, even though you give byte, the compiler will ensure that this byte is getting converted to int. Byte is getting converted to int. Okay, and then it will start performing the exact operation. Okay, but let us say if you are using short, no matter what data type you use, by default it will consider, it is going to consider it as what it internally it is going to convert it to int, then it will perform the manipulation. Okay. So let me put it in a different way. See, even though you do byte, so let us try to trace this program for the better understanding. Okay, let me use this space. Focus here. Focus here. Let me use this space. We know these things already. Compilation will happen, main thread will be created, main thread gets access to the main method, right? All the instructions inside the main method gets executed. Now first instruction is, okay, it is finding, okay, the value 5 is getting assigned to the variable A. Okay, what is happening? The value 5 is going to get assigned to the variable A. It means internally 8 bits of memory will be created, yes or no? Okay, what will happen internally? What are the things that will happen internally? 8 bits of memory will be created for the byte data type, right? Right? And what is the equivalent? Okay, what happens next? The decimal number 5 will be converted to what? It gets converted to the equivalent binary number. What is equivalent binary number for the decimal number 5? Anyone?
101.
101. So 101 and the remaining bits will be filled with zeros. Right? And the variable A will be assigned to this memory registry. Okay, but okay, when the compiler will check the next statement. But since it is a command, it is going to get ignored. Okay, what we call it as the main thread will try to find the next statement. So it is a commands, right? So the commands will be ignored, and the next statement is what you are saying: system.out.println, and the main thread will identify. Okay, this programmer is using what? This programmer is using triple right shift operator. This programmer is using triple right shift operator. Okay, it will ensure that this registry, this is a registry of what type? Byte type. This registry is getting converted to int type. When I say that, okay, when I say that, so what is the size of int, guys? Can anyone help me with that? What is the size of int data type? Anyone? How many bytes of memory is going to make int data type? 4 bytes. You agree with me? Yes or no? Yes or no?
Yes.
Answer. Yeah. So byte is what? A byte is going to be of 1 byte. Okay, int is going to be, 4 bytes of memory is going to make the integer data type. Having said this, what I have just said, the moment the moment the main thread identifies the triple right shift operator, it is going to convert this to what type? In data type. When I say that, okay, it is going to make 32 bits of registry. 8, 16, and what is this? 24 and 32. It's going to create 32 bits of registry. Why 32 bits of registry? Just now I explained now. Why 32 bits? Why 32 bits? Because as soon as the triple right shift operator is identified, whatever the variable name that you give, it will try to find what kind of declaration is there. The declaration is byte. But the compiler, okay, during the runtime, this is going to get converted to the integer data type by default. Okay, so now all the values from the byte data type will be transferred to the int data type. Okay, this is of 8 bits, 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 totally 32 bits. Okay, 32 bits of register will be created. Everything will be what? Everything will be, okay, every value from this registry will be transferred to this registry. So now here you will get 1, 0, 1, and everything will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. Every bit will be filled with zeros except for the first 3 bits. Right? After this, it will perform the actual shifting. So what we want to perform? A triple right shift of 1. A triple right shift of 1. So what happens? Okay. Now let me take the same size. I will repeat this once again, don't worry. Okay, now what we are doing? This This A will be what? Triple shifted to one space. Okay? One bit. What does it really mean? Okay, the first will be shifted here. Means it will be moved out of the registry. The remaining bits will be shifted accordingly. Okay, this zeroth bit is going to get this position, and this one bit is going to get this position, and so on. Okay, if you fill that, okay, this is going to be like this: 0, 1, 0, 0, 0, 0, 0, 0, and everything will be 0. Everything will be 0. Except for the last MSB, everything will be 0. Okay, because this last MSB is going to get shifted here, so there will be a void space will be created. There will be an empty space will be created. Okay. What the triple right shift operator says, whenever a void space is getting created, fill that void. Always fill that void with 0. Always fill that void space with 0. Making sense? Now calculate the equivalent decimal number. So the triple shift operation is done. The triple shift operation is done. Okay, the triple shift operation is done. This is the equivalent binary number for the value 5, right? And this is what? And this registry is giving what? 5 triple shift of 1, and this is the equivalent binary value that you are getting. So we have only one bit is holding the value 1. So if you make 2 to the power of 0, 2 to the power of 1, 2 to the power of 10, if you keep going on, okay, except for this value, everything is going to be 0. So 2 to the power of 1 is going to be right? 2, right? Yes or no? Okay. Shall we check if our answer is correct or not? Let us check that. Okay. Same query, same problem I am taking. I am saving this. A.java. Right? What is the file name? A.java. So it should be saved inside a folder called this one, Java2 folder. Okay. Let us start performing the compilation. Command prompt. Let me change the directory. cd space java2, java c space a.java for the compilation. So the cursor is blinking. It means there are no errors in this program. So I can directly perform the execution. Java space a. You are getting 2. You have the same answer, isn't it? 2 is matching our explanation, yes or no? Let me repeat this once again. Let me explain this once again. If you have a question like, okay, if you want to do a triple right shift, if you want to use a triple right shift operator, okay, first thing you should keep in mind, what is that? By default, it would use the integer data type. But the question is, in our program, we have taken a value, and that value is getting assigned to the byte data type. Okay, for this, it is going to do what? It is going to create a registry of 8 bits. Because 1 byte is going to hold how many bits? 8 bits. Okay, this 5 is a decimal number. Okay, the 5 is a decimal number. It is going to get converted to the equivalent binary number. Okay, the equivalent binary number is going to be 101. Okay, the 101 will be filled accordingly from right to left. 101. Okay, the remaining spaces will be 0. Okay. What is the next line? Okay, this line is completed. Okay, what we are doing here, we are performing the triple right shift operation. Okay. So triple right shift operation means the Java will do the conversion. What conversion it will do? It will convert the byte data type. It will convert the byte data type to the integer data type. But if you want to calculate the number of, if you want to calculate the memory of int is larger than the memory of byte. So memory of byte is 8 bits. Memory of int is what? How many bits? They are going to be about 32 bits. You calculate everything. If you calculate these 8 bits and these 8 bits, these 8 bits and these 8 bits, you get 32 bits. Okay, the 32 bits of registry will be created. All the values from the A variable will be copied or will be transferred to the new registry of 32 bits. Okay, and the remaining bits, okay, will be filled with 0 accordingly. Then the actual triple shift operation is getting performed. Okay, triple shift to what? Triple shift to one number, right? So one number means the first number will be moved out, remaining number will fall inside accordingly, according to the shifted number, according to the shifting number. Okay. While doing this, a void space will be created because the last number will get this position. A void space will be created here. That void space will be filled with 0. After doing this, you convert this registry. Okay, you convert this registry to what? To the actual binary number. So you will get what? You will get 2 as output. Understanding this, everyone? If you want to understand this, you should understand the first two topics which I have covered. Can you answer? Are you able to follow this, everyone? Teja, Dinesh, uh,
Yes, sir.
yeah,
What difference does it make, sir?
what?
What difference does it make unless it's wasting so much memory?
It will not make any difference. So we are going to solve some DSA problems. DSA problems means we are going to solve problems in the machine language. So in there you are going to get a lot. It will make a lot of sense. First of all, triple right shift operator are used to perform some internal logical operations. So we are going to that classes in the next week. There you will understand. Now try to understand how the triple right shift operator is functioning. We are trying to understand the functional view, then we will try to understand the actual purpose, its actual purpose. Yes, of course, memory is getting wasted. You are going to see the actual purpose in the future classes. Okay. Now you are going to see a great difference. Okay. Now you are going to see a great difference since we are using the positive number. You are saying that the memory is getting wasted. Okay. Now let me. Actually, Sudhir has asked me a very good question. He's asking me, what's the point of using this operator when there is a lot of memory is getting wasted? Okay. That answer will be understood when we are learning the Java data types. For now, try to understand the functionality. Till now, we are dealing with positive number, but I just want to change this to the negative number. Now, A is -5. Now, I am making the A as -5. -5 is a value getting assigned to A. If I try to compile this, you will see a lot of difference in the output. I mean, if I try to execute this, what I mean is, see, you are getting a very big number. Okay. If the interviewer is asking you this question, you will take at least 5 minutes to answer this. What is this? What is happening? Only the signature is changed, only the sign is changed. If it is positive, okay, there is nothing. It is positive, we don't see any difference. Whereas when you change the number to negative, if it is positive, okay, the answer is 2. But the moment you change it to negative, and look at the change behind the scenes, okay, you are getting a very big number. Why you are getting a very big number? Okay, shall we understand this, everyone? Say yes or no. Shall we try to understand this?
Yes, sir.
Okay. Now you see, same. Let me copy the same code. Okay. Only the code that is inside the main memory I am copying. Okay, I am pasting it here. Okay. Remove this. Okay, this comment is not necessary for us. Remove this. Only 2 lines of code. We are getting a very big answer. The first line, the main thread is going to check this instruction. It says -5. Okay, firstly, you know how to store a binary number that says -5. Okay, first try to calculate the equivalent binary number for +5. +5, we know that already 101 is the equivalent binary number for the +5. Okay, now you see, guys, now the interesting things will happen. So there is a problem here. The compiler, I mean the execution will find, okay, this person is using triple right shift operator. The person is using what? The person is using triple right shift operator. The person is not using triple right shift operator. Just an assumption. Just imagine that you don't have this. Just imagine that you don't have this. Okay. You want to convert. You want to find the equivalent binary number for -5, -5. +5 is this. Okay. How do you find it for the -5? How one would find it for the -5? Let me take this. Okay. Now focus here. For +5, we know that, okay, the 101 will be there. 101 will be there, and remaining things are going to be 0. Okay. To find the -5, we need to perform 2's complement. So, firstly, even though we have to perform the 2's complement, before that we need to do one thing. We need to start finding 1's complement first. Yes or no? Tell me how the 1's complement number is going to be. Everyone with me? What is the 1's complement for this number? Just flipping the numbers, isn't it? Hello?
Yes, sir.
Yeah,
Yes.
so it is going to be what? 0 means 1, 0 means 1, 0 means 1, 1. Just flip it. If it is 1, 0. If it is 0, 1. If it is 1, 0. So this is the equivalent 1's complement. Yes or no? Equivalent 1's complement. Right? And again, you want to find what? You want to find 2's complement. Okay? 2's complement is just add a 1 after finding 1's complement, add a 1 upon 1's complement binary number. You will just add a 1. So what would be the answer? 1, 1, 0, 1, 1, 1, 1, 1. Yes or no? So this is going to be the answer. Right? If you convert this to the equivalent binary number, what did I say? Whenever you're using 2's complement, always you have to ensure that you need to ensure one thing. What is that you need to ensure? Okay, you need to ensure what? You need to ensure MSB, most significant bit. So this is going to represent the signature. This number is going to represent the signature. I'm sorry about it. This number is going to represent the signature. Right? So let us try to raise the powers. Okay, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. Okay, so this number is representing the signature. If it is 1, this is representing the negative number. Negative number, right? So 2 to the power of 7 is what? Anyone? Minus 120, 128? Yeah,
128.
128. Since this 1 is representing a negative number, put a negative sign of 128. Plus 2 to the power of 6 is what?
64.
64. Plus 2 to the power of 5 is what? 32, right? Plus 2 to the power of 4 is
16.
16. Right? 2 to the power of 3 is what? 8, right? 2 to the power of 2, you don't calculate this. Why? Because 0. Because the bit is 0. Even though bit is 0, you won't calculate. 2 to the power of 1 is what? 2. Plus 2 to the power of 0 is what? 1. Okay. Add all these things, what you will get? Tell me quickly. 128 minus 128 plus add everything. 64 plus 32 is what? 96, 106, 112, 120, 122, 123. 123, yeah? Okay, these things will give us 123, right? Plus 123.
Yes, sir.
Okay, then minus 28 plus 123 is what? Minus 5. Are we getting the same number? I'm just explaining it, nothing. I'm just explaining how do you find minus 5. You do what? You do 2's complement, yes or no? After doing 2's complement, okay, this is the equivalent binary number for minus 5. That's what I'm trying to say. Okay, now the problem, there is a problem here. Let me remove all this. Now focus here. Okay. So now let me consider this piece of line also. If we are using what operator? We are using triple right shift operator. Triple right shift operator means internally, don't you think that it is going to consider integer? Integer means how many bits? 32 bits, yes or no? Just now I explained, right? Yes or no? 32 bits. Okay, 4, 8, 16. Thirty-two bits of registry. Okay, you want to store the negative 5. You want to store what? You want to store the negative 5. Okay, first you calculate the binary equivalent for positive 5. We know what is it? 101. Yes or no? 101. 1, 0. Let me take it here. 1, 0. Fill the remaining spaces with 0. Okay, because it is taking integer by default, it will take integer data type. Triple right shift operator means it is going to take integer data type by default. It is available only in Java. In Python, you don't have triple right shift operator. Okay, they haven't given that in Python, but in Java you have. You will understand its actual benefits in the future classes. But the idea is triple right shift means it is going to consider the integer data type. Integer means 4 bytes of memory. Right? 4 bytes of memory means you need to create 4 registries of 1 byte. So this is 1 byte, this is 1 byte, this is 1 byte, this is 1 byte. Totally it is making 32 bits. If you want to store the binary number 101 in the 32 bits, this is how it looks like. Right? First, rightmost 3 bits is going to be filled with the number, the remaining space are going to be 0. This is for positive 5. This is for positive 5, but you need to calculate for negative 5. Negative 5 means 2's complement, yes or no? 2's complement means if you want to do 2's complement, first of all you need to do what? You need to do 1's complement. Then you will add 1 upon it. Okay. Let me create the same registry again. Focus here. You will not have this nonsense from tomorrow. This is going to be completed by today only. You will understand its real importance, the data structures concept. Let me repeat it once again. This is for positive 5. This registry, this complete registry is for positive 5. But you want to calculate for negative 5. To calculate for negative 5, first of all, you need to do what? You need to do 1's complement. You need to do 1's complement. Okay. How to find the 1's complement? Just flipping the numbers. When you find 1, flip it to 0. Okay. When you find 0, flip it to 1. When you find 1, flip it to 0. Do you think that remaining numbers is going to be 1? Everything is going to be 1 because you are just flipping from 0 to 1. 1's complement is just flipping. Okay, just writing the opposite bit. Okay. Upon 1's complement, you will do 2's complement. Okay, just to get 2's complement, you will just add a 1 upon it. Making sense? Now you do what? Now you do. Okay, you let me copy this. Let me paste it here. Everything is going to be same. Everything is going to be same except the last number is going to be 1. Let me erase this. This is going to be 1. Okay. So this is the equal, this is the minus 5. Minus 5 getting represented in the int registry. Okay. You will think that this is such a big number. You will think that this is such a big number, but again if you calculate, okay, if you consider this, you consider the MSB, if you consider the MSB as the negative sign, you consider the MSB as a negative sign, you will get a very big value. You will get a very big value because it is of 2 to the power of 31. You will get a very big value, but the remaining values are going to be smaller than this power. Remaining values are going to be smaller than some value will be there smaller than this power. Okay, you will get a value minus 5. If you want, you can. If you want, you can try them. Are you able to understand? Sir, if I try to convert this binary number to the decimal number, okay, can I get minus 5? Yes, you can get minus 5. Why? Because the most significant bit is 1. Means it is occupying the topmost power. Significance of the power is about 2 to the power of 31. If you find 2 to the power of 31, you will get a big number. And the following number is going to be what? So this is going to be negative. Negative big number. Following is going to be what? Positive smaller number. Okay, these remaining things are going to be smaller than this number. Smaller than this number. So the difference is going to be minus 5 only. If you want, you can try. Okay, so we have found the equivalent binary number for the minus 5. Then do the triple right shift. Then do the triple right shift. If you do the triple right shift, okay, that is very simple. Okay. Getting the same one now. Okay, let me copy this once again. Only if you have pen and paper, these things will be very easy. If you just try to imagine these things, okay, it will not make any sense. Imagination will not be helpful here. Now you are actually doing triple right shift of 1. Okay, now minus 5 is getting triple shifter to 1. So this entire part is minus 5, right? That is getting triple right shifter to 1. Means this first value will be eliminated. Remaining things will be falling like this. Every value will be shifted to one's position, right? When you do that, okay, this is going to be 1, this is going to be 0, right? Every other values are going to be filled with 1. Okay, so this is going to be here. The last space is going to be void. The last space is going to be void because the moment you do shifting, definitely one space will be void, right? That void space has to be filled with 0. That void space has to be filled with 0. You calculate the equivalent binary number from year to year. Okay? Trust me, definitely you will get this number. What is the number that we are getting here? If you this is a task for you. If you want, you can try. You can try after this class. Have you understood, everyone? You can ask me any questions, guys. Because if you are not asking me now, you cannot ask me in the future also. Everyone, making sense? Yes, no? Sudhir,
Yes, sir. Understood.
Teja, Srikanth, Purnima, Dinesh, Lakshmi. Okay, I'm assuming that you have understood this topic, triple right shift operator. Go to the theory. There is a theory. Okay, theory says by default it would use the integer data type. It is also called as unsigned right shift operator or logical right shift operator. Apart from this, what else we can add? Apart from this, what else we can add? We can also add like the void space that is getting created should always be filled with 0. Please be informed that the void space is getting created should always be filled with 0. Right? This is the void space I'm talking about. The last space. The last space, a void will be created that should always be filled with 0. Right? And I think, okay, this is what the explanation is. So this is what all about the triple right shift operator. Okay. And what is the next operator? Okay, let us try to understand the difference also. Difference between triple right shift operator and the right shift operator. The actual right shift operator. Right shift operator. What is right shift operator? This is right shift operator. We have discussed these things yesterday. And the difference between right shift and triple right shift. Right shift operator. Right shift versus triple right shift. Yesterday we have discussed about right shift. It is also called as what? Arithmetic right shift or signed right shift operator. Also called as arithmetic right shift or signed right shift operator. Okay. So this is also called as logical right shift or unsigned right shift operator. Logical right shift or signed right shift. In this case, in the MSB, it is always the MSB that is used as a filler. most significant bit. Actually, we have seen these things. Okay, let me show that for you. I don't know if you remember that or not. So when you are dealing with the right shift operator, right? Not this one, I think. Next slide. This one. Okay. So you are going to fill the void space considering the MSB of the binary number. The void will be created if the actual binary number is 1, you will fill that void space with 1. If the actual binary number is 0, you will fill this number with 0. This is what we have discussed in the extra class for the right shift operator. Okay. Same thing I am giving it here. It is always MSB that you will fill as a filler. Fill. Okay, but here it is always 0. It is always 0 for the void space or the filler. So for the right shift operator, for the triple right shift, one void space will be created. So what you have to fill some numbers for that void space. For right shift operator, you will choose MSB. But for the triple right shift operator, you will always consider 0. It is always 0 for the void spaces or fillers. Okay. Here, the signature of the number is always preserved. The sign of the number is always preserved. Here the sign of the number is not preserved because you are not choosing MSB. That's the reason why you are not using the to fill the void space. You are not choosing the MSB value. That's why the sign is preserved. Here you are not considering the what MSB, so sign is not preserved. Sign of the number is not preserved. Those who are not understanding what is MSB and all, watch my previous videos will understand. Okay. One important point. This triple shift right shift operator is available only in Java. In Python, it is not available. Python, in some programming languages, it is not available. Or I can say that Python does not support triple right shift operator. Why we are discussing Python here? Just to show the difference. Only in few languages it is enabled. We will get to know that reason shortly. People about this operator shortly. Right? The one last operator is pending. What is that? Bitwise operator. Bitwise operator is very easy to understand. Okay, let me copy this. Let me save this file. Save as ng. Today is class 31. Class 31. File. Okay, sir. Bitwise operators. Okay, the symbol that you are going to use to represent the bitwise operator is tilde symbol. So it is just above okay, this is the symbol. Tilde symbol. We can say it is as what? Tilde symbol. Okay. So how do we deal with the triple right shift operator? That should be the question, right? How we are going to deal with the triple right shift operator? Very easy. Let me take an example. Okay. If you want to perform triple right shift, I mean not a triple right shift, bitwise operator. Let me remove all this. I just want to do bitwise upon number 2. I want to do bitwise upon number 2. How we are going to do this actually? What is the answer? First we'll try to find the answer first. Okay. Java C space a dot Java space. We're getting -3. So -3 is the answer. Okay. What is happening behind the scenes? What is actually happening behind the scenes? Very simple. Very easy. Let me copy this instruction. Let me put it in the paint screen. So we are using what? We are using the bitwise operator with a number. A registry will be created. 8 bits of registry. Okay. 8 bits of register. What is the equivalent binary number of 2? Anyone help me? What is the equivalent binary number for the decimal number 2?
10.
1 0. Okay. So everything will be 0. Okay. This is the actual binary number representation for the decimal number 2. Okay. After this, what we are doing, we are saying bitwise it. We are using the bitwise operator upon this number. We are using the bitwise operator upon this number. Always remember, whenever you are using bitwise operator, ensure that it is getting prefixed with a number, not suffixed. It should come before the number. It is not supposed to be like this. It cannot be like this. You should use this before the number. This is valid. This is completely valid. Okay, this is invalid. Okay, so 8 bits of register will be created, and okay, so this is equal to binary number. After this, simply what you do, very simple. Simply flip the numbers. The 0 becomes 1, 1 becomes 0, and zeros becomes 1, 1, 1, 1, 1. Just flip the numbers, or I can say that just do what? Just do the ones complement. Just flipping the number is enough. After flipping the numbers, you will get these as the values. Right? You will get this as the values. Consider the MSB. Okay, this is MSB. You call it as what? You call this as MSB. This part is MSB. Okay? And the remaining part, this part you can also call this what? The actual magnitude. Magnitude. Okay? Now perform the evaluation. This is what 2 to the power of start from the left to right. Right to left. 2 to the power of 0. 2 to the power of 1. 2 to the power of 2. Which I can do like this. Quite confusion. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. So this is in yellow, means this is MSB. This is representing MSB. What is the equivalent value for 2 to the power of 7?
128.
128. Since it is in the post, since it is holding the 1 bit, it is negative 128. Plus, okay, what is 2 to the power of 6? 64. Right? What is 2 to the power of 5? 32. What is 2 to the power of 4? 16. What is 2 to the power of 3? 8. What is 2 to the power of 2? 4. What is 2 to the power of 1? 2 only, but you don't take this because 0 is there. Right? What is 2 to the power of 0? 2 to the power of 0 is 1. Okay? What is the value that you get after this manipulation?
125.
Okay, so I can say minus 128 plus 125, isn't it? Right? What is the equivalent? What is the number that you get? Minus 3. Right? Are we getting the same number? Minus 3. Right? Now you find, okay, try to find, if you have pen and paper next to you, always keep pen and paper next to you. Try to find the triple right shift of, bitwise of 3. Come on, everyone. Find, I will give you 30 seconds. Bitwise operator of 3. Let's see who is going to find it. Everyone trying, or everyone are waiting for others to try? Trying, or should I explain it?
Minus 4.
Minus 4, right? Okay. Let us see if Sudhir is correct or not. Java is Java. That's minus 4. Okay, I will tell you the formula. Okay, now you are able to understand how do we find the equivalent bitwise equivalent number while doing the bitwise operation. Okay, now the question here is, for the positive numbers it is okay. I want to take the negative number. Negative number is also easy, guys. Negative number is also easy. I want to find the bitwise upon minus 2. I want to find bitwise upon -2. Very simple. Don't need to keep any confusions here. First of all, don't get panicked. The question is what you need to find for -2. Okay? First, always remember to find the equivalent binary number of positive 2. Okay? Equivalent binary number of positive 2 is what? 1, 0, isn't it? 1, 0. Okay? 1, 0. And the remaining remaining bits are going to hold zeros values. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits of registry will be created. This is the equivalent binary number for positive 2. This equivalent binary number for positive 2. But you want to find the equivalent binary number for negative 2. How do we find that? First you need to use 2's complement. Okay? First do the 1's complement, upon 1's complement do the 2's complement. So when I do 1's complement, you will just flip the numbers. For 0 it's 1, for 1 it's 0, and remaining numbers are going to be what? 1, 1, 1, 1. Right? After this you will add 1 upon it. You will add 1 upon it. So this is the 1's complement. Okay? You need to find 2's complement. 2's complement is you will add 1 upon 1's complement. Right? So 1 plus 1 makes 10. Right? And carry 1, and it is going to be 1 only. 1, 1, 1, 1, 1, 1. Okay, this is the equivalent binary number for -2. This equivalent binary number for -2, isn't it? Okay. Now what we want to do? We want to perform what? We want to perform the bitwise operation. Bitwise operation on -2. First, find the equivalent binary number for -2. Then perform bitwise operation. Okay. A tilde symbol. What does it mean? Just flip the numbers. So 0, 0, 1 becomes 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 0, 0 becomes 1. Okay. This is the final answer. This is the final answer. If you convert this to the equivalent decimal, what is the answer? At least tell me this. What is the equivalent decimal number for these binary numbers?
1.
1 only, right? Should we get 1 or not? Let's see. Are we getting 1 or not? Bitwise operation upon -2. Okay. So by looking at this pattern, I have arrived to a conclusion. What kind of conclusion? By looking at these answers. By looking at the answers that we are getting, for the positive number and for the negative number, whenever you are using the bitwise operation, okay, so for any number n, okay, 1 minute. For any number n, we are performing bitwise operator upon any number n. Right? The formula is what? The formula is n plus 1. Minus of n plus 1. Okay. If it is a negative number, it is minus n. Just replace the n with what? The minus. Let us see. Initially we have taken bitwise operation upon 2. Okay. Just replace this n with 2. 2 plus 1 is going to give what? -3. Now we have taken what? Bitwise operation upon -2. Right? And I have given a problem. Bitwise operation upon 3. Right? Minus of n plus 1. N is what? N is 3. 3 plus 1. 3 plus 1 is what? 4 is -4. We get -4 or some other thing. -4 only. See, -4 we got. If it has found this, no? Then what is the case? What is other case? So we have just calculated the bitwise operation upon what? Upon what number? Now, the bitwise operation upon -2. Right? Just replace n with -2. Minus of -2 plus 1. Right? Minus of -2 plus 1 is -1. Right? So again minus gets plus, the answer is 1. Okay? If you get a question like, hey, can you please find the bitwise operation upon okay? Without doing all this, if I ask you, hey, can you please find the bitwise operation upon 5? Now you answer me by using the formula for 5. So this is the formula. What is the bitwise operation upon 5? Come on.
-6.
-6. Very straightforward, right? Just replace this n with 5. 5 plus 1 is going to be 6, and apply and you have the minus here, -6. Hey, can you find the bitwise operation upon -5? Now what is the answer?
4.
4. So, everyone getting this? Okay, if you get a question like do the bitwise operation upon, you can remember this formula. Okay, I have asked you to find for 5. Are we getting the same value or not? Let's say minus 6. Okay, and for minus 5, for bitwise operation upon minus 5, Sudhir has just said what 4. Aren't we getting 4? It applies for all the values, right? For minus and positive, for positive number, negative number. Don't you think that just remembering this formula is enough? I can just give you this formula, but you should know what is actually happening behind the scenes. This is what is actually happening behind the scenes. Everyone understanding? Okay. Tomorrow, what we will do is, okay, we have understood all the operators, all the bitwise operators. Tomorrow, we are going to see the complete depth, deep information about the byte data type. Even though if you understand this or if you don't understand this, no problem. Okay, because this will be used in some interviews for the Java data structures questions, right? But from tomorrow, we are going to understand the byte data type. It is going to be it is going to take at least 1 hour. 1 hour. You are going to analyze deep into it. Okay, don't skip tomorrow class. From tomorrow, don't skip any class. You will see a lot of problem solving. Lot of problem solving will be there. The question will be, see, the questions will be like this, guys. In the interview, they would ask you, I will give you an example. They would say, byte b equal to 10. Okay, and they would say, byte c equal to 20. Okay, and they would ask you to find byte d equal to b plus c. Okay, now you tell me, as per your understanding, what could be the output? Everyone tell me. I have instead byte b equal to 10, byte c equal to 20, and I am taking a variable d and I am adding b plus c. B plus b is 10 plus 20. What would be the answer?
30.
30. What about others? Only Sudhir is answering. We agree with Sudhir. Teja is there. Srikanth is on hold. Lakshmi is there. Purnima, Dinesh is there. What about others? Yes, sir. Okay, Sudhir says it's 30. Let us do this. Java C space A dot Java. Java space A. No, sorry, I did not save it. Java C space A dot Java. It says incompatible types, possibly lossy conversion from input. Why we are getting this question? In the interview, they would ask you directly, hey, you have byte, you have 10 as assigned to B, you have 20 assigned to C, and you have B plus C equal to D. What would be the D? Blindly, you will say 30. Okay, but 30 is a wrong answer. Okay, but when you say get this error, they would ask you the follow-up question, why you are getting this incompatible type error. Compatible type error. So if you are not answering that, they would ask you without knowing this, how did you learn Java? Very fundamental. These things will be explained tomorrow. I will tell you why this is incorrect when we are trying to understand each and every data type in detail. You will get that insights. Right? All the last 5 classes